to, like you say, party out on a weekend.
Okay, we're going to be working with composition of functions. That's what we're going to deal with today. We have already talked previously, earlier this year, what the designation of a functional notation was, and that functional notation looks something like this. Remember working with f of x's and g of x's and so forth at that time? Huh? Okay. We also said, what if I wanted to find the value of f of 5? What did we do with that 5? Okay. So if we did that, we had 2 times 5 plus 3, so that would equal 13. Correct? Remember doing that? Okay, awesome. Did all functions have to have an f of x? Nope, they could have had like g of x, could have had h of x, could have had q of x. So basically any letter that I wanted to use would designate it as a different function, right? Okay. We are going to talk about 4 different compositions today using the functional notation. Those 4 compositions are going to be f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So it's basically meaning that I'm going to take 2 functions and I'm either going to add them together, subtract them, multiply them, or divide them. Well, this definition of f plus g of x can also be written in another way. And that another way could be f of x plus g of x. So basically I'm going to take the f function, whatever it's going to be, and add it to the g function, is what it means. Okay? So if I was given f of x is equal to 2x plus 3, and g of x is equal to 4x minus 7. If I said I wanted to find f plus g of x,
4x minus 7.
4x minus 7. If I wanted to take f plus g of x, it also implies that I'm going to take f of x and add it to g of x, doesn't it? Well, what's the f of x function? What's the g of x function?
4x minus 7.
So I'm going to add that to 4x minus 7. Okay? Which means then that the f plus g of x, well, if I look at these two, can I simplify this in any way, shape, or form?
Yeah.
We've been adding similar terms together and so forth, right? So if I had f plus g of x, what would this simplify to?
6x minus 4.
That would be the f plus g of x. So that's not so bad now, is it?
No, but I bet there's more.
So what do you think it would be if I said f minus g of x?
It would be 2x plus 3 minus 4x minus 7.
2x plus 3 But be careful here, it'd be minus this whole quantity of 4x minus 7. Right?
You have to distribute the minus.
I'm going to have to distribute. Right? Because a negative times the 4x is going to give you a negative 4x. And a negative times a negative 7 is going to give you a positive 7.
Oh, my.
Because I'm subtracting the g of x, right? So what's that going to simplify to?
Negative 2x minus, or plus 10.
Okay? We all right with that? Okay. So if I had the function h of x equals 3x minus 5 and f of x equals 4x. Can I do an h minus f of x?
Yeah.
If I did an h minus f of x, that means that I'm taking h of x minus the f of x, correct? Which means that I would have what type of expression here? 3x minus 5 minus 4x.
So what it'll always give you, and like in the book and on our worksheets, it'll always say like h of x equals and f of
Yep.
x equals.
Yes.
Alright.
And then
It'll tell you which one to do?
Well, it'll tell you which one to do, because, you mean like this part? Yeah. Okay. So if I simplified this, what would I have?
Well, negative 1, no, negative 7x minus 5. It'd be negative 1x.
Right?
So negative 1. Yeah, I did. Well, because the last one I meant that we changed the sign.
I did the-
added the negative sign to distribute or whatever, for some reason last time.
Well, we did the same thing here by taking the negative 1 here times this 4 to give me a negative 4x. Would it be different if I said this?
Yeah.
What would be different about it?
Your custom minus,
So I'd have 4x minus parentheses 3x minus 5. Have to do the distributive property. Correct? Which would be 4x minus 3x plus 5. Because a negative times a positive gives me negative. A negative times a negative gives me a positive, doesn't it? So that's going to give me x plus 5. Okay? Bless you. So what if I go to one like this? H times f of x. That implies I'm going to take h of x and multiply it times f of x. Do you agree? So what's the h of x?
3x minus 5.
And I need to multiply that by the f of x, which is 4x. So what's that going to give me if I have that?
12x squared minus 20x.
Right, because 4x times 3x is 12x squared. 4x times a negative 5 is a negative 20x. Okay? A little bit of a pattern. It's not hard. Do you agree? Okay. So the last one would be, what if I had h of x over f of x? That would be a division, wouldn't it? Which means that would imply taking h of x, which is 3x minus 5, dividing it by the monomial 4x. Is there a common factor between 3 and negative 5 and 4? Is there a common factor between the x, nothing here, and an x? So I probably just leave it as 3x minus 5 over 4x, similar to the division rules that we just talked about before. Is there another way that I could have done this because it's a monomial?
Put the 5 on the bottom, put the 3 and the 4 together.
Okay, I could have written it as 3x over 4x, remember when we separated it, minus 5 over 4x. Remember separating that yesterday? Can I reduce this?
Yeah.
What would that reduce to? 3/4. Can I reduce this? So I would have left that as 5 over 4x. This one right here is the most standard answer. Better than this one. But both of those are correct. Okay? We'll stop this one and then we'll continue.